Let's have a look at the BigTreeTech SB2209 and SB2240 Canbus boards designed for stealth burner. This came shipped in a nice box, as usual, black with the red logo. And I bought the kit that contained the SB2240 along with the Canbus cable. This is a 4-conductor Canbus cable. 2 of them are extra nice heavy gauge to handle all the amperage you want to, as well as the high-low signal wires with a special plug. It's a really beautiful cable. We've got the prerequisite thank you card, and of course, the prerequisite rubber ducky. Wouldn't be complete without it. It comes with a couple of decals, 3 to be exact, as well as some tie wrap. And then as usual with BigTreeTech, it comes with your standard set of connectors and terminators, the heatsink as well, which is kind of nice also. These connectors are small. Um, I had a hard time with many of these actually getting them connected. You may want to go ahead and maybe order some that are pre-terminated to graft on to the wires. But again, it really comes with everything you need here. So it comes with 2 cards. It's a 2-card PC board setup. The first being the SB0, and this is the PC board that connects behind the blower in the stealth burner. And it's a really nice, well-made board. Looks like high quality. It's got an extension here for Canbus with the voltage and the high and the low. It also has space for 3 fans, 2 standard and 1 PWM, as well as the RGB. And this is the piece that when you pull off the front of stealth burner, this board comes with it. So it really solves the problem of all the wires that you normally have back there. And this is the main controller card with the CPU and with, in this case, the 2240 driver or the 2209 driver. Here you see where the Canbus cable plugs in as well as the USB-C. We've got all the connectors here, the 1.25 millimeter connectors, and the reset and the boot switch, and really all the sockets you could possibly want for connecting really anything else that might be on your printhead. To connect this to the Pi, I decided to go ahead and use the BigTreeTech U2C. This is a CAN bus to USB interface. I have used it in the past and I really like it. I think it's a great CAN bus card to use. I don't run this or connect this off the MCU. You can also go ahead and try the USB straight connection as well instead of this card, but I've had really good luck with this card and I see no reason to not use it. I really like the idea of having one USB port on the Pi dedicated to the full MCU and the other one to CAN bus. I think it eliminates a lot of possible bandwidth problems. This thing has connections galore. I tend to use these screw-on connectors for the bare wires. Here you can see where the USB-C connects. There are other USB connections as well as many different CAN bus connector styles as well too. The BigTreeTech GitHub site also contains some STL files. Here's a mount along with a clamp for the top for the Canbus cable in the printhead or on the printhead. And in addition, you'll need to go to the stealth burner site and print out this additional card adapter to allow you to mount the SB2240 to the side of the printhead. Here's the front face, the stealth burner with the blower and the fan. And there are actually 2 holes here already in the stealth burner printhead, or at least in this cover. And so the PC board simply pops in place and use the 2 included screws to bolt this in. Once you're done, you're going to have to re-terminate the fans because you're going to have to switch these to DuPont connectors, but it's easy. Once you've got the fans and everything terminated properly with DuPont, here you can see they plug in, that's the blower. In addition, here's the hot end fan and then the RGB connector. And then in between these two, you've got an additional fan if you needed, the PWM fan, and there's the Canbus extension. And then here we've got the socket that's used to plug it in to the main Canbus board. Here on the SB2240 main board, at the front here you can see the pins, which is what the front face will mount to. And here you see the voltage settings. You simply use a jumper to set these to 5 volts, 12 volts, or 24 volts, all independently, depending on what type of fans you're using. I use 24-volt fans and blowers all the time, and so I simply went ahead and set these all to 24 volts. And again, this is all really, really well documented in the manual. And make sure you go ahead and do this for your other fans as well. Make sure the voltage is correct. Here with Stealth Burner partially disassembled, you can see the heat set inserts that this will bolt to. Here I've got the two hex bolts already inserted. And if we take a look at the other side, we can see the adapter plate that's available at the Stealth Burner GitHub, the STL for this circuit board adapter. And so here I'm simply setting this up so I can bolt this in. Here it is, bolted in. I'm going to use some iso alcohol, 90 or more proof. And here I'm cleaning the little area where the heatsink is about to be attached to. And it's a self-adhesive heatsink like any of the other ones you've ever used. Super easy. As you can see, there's another pad for another heatsink. It didn't come with one, and so I'm going to assume it's okay that I don't put one there. But I may go ahead and place one there as well. Depending on how and what everything was connected beforehand, you may again have to re-terminate many, if not all of these wires. Also here I'm connecting the stepper motor, plugging it into the board. It plugs in the back like so. You'll also need to go ahead and connect the umbilical mount. And it's really just support for the connector. I believe it also supports the USB cable if you choose to connect that way as well. So here you can see everything connected. It does a fantastic job of eliminating all the wiring, or almost all the wiring, hanging out the back of the print head. If you've used any of the other solutions for Canbus, it's certainly one of the issues you have to deal with and try to resolve for reliable printing. And this pretty much takes care of it for you. In the name of reliable printing, also the other thing you need to do is make sure the Canbus terminator is installed on this card if this is your only device. You also need to install the terminator on the other end on the U2C controller card, or whatever it is, the MCU or whatever it is you might be using that's connecting to Canbus. So now it's everyone's favorite software, flashing BIOS. Because I'm using the U2C, I'll have to flash it first. And so here you have it, see it connected to my DIN rail. I've got the 24 volts power connected on the left here. And I don't have anything else connected here. And I will plug in now the USB-C cable that's coming in from my Raspberry Pi because I'm going to be using my Pi to actually flash this. You should see all the LEDs light up, and I'm actually going to darken the lighting here so you can see it. With your bare eyes, I'm sure you can actually see it fine when you're doing this yourself, but due to camera and lighting, it's a little bit hard. So here goes. So with all that complete, let's install the software on the SB2240 or SB2209. To start here, I've logged into my Pi via SSH. Make sure we're in the Klipper directory. And then let's simply run make menu config. And once we're in the app, we want to go ahead and enable the extra low-level configuration option. We need to select the microcontroller architecture and its STM. And we need to select the processor model. By the way, I'm pulling all of this from the manual. I'm not going to use a bootloader. You can, and it can make life a little bit easier when you choose to upgrade software, but I'm going with no bootloader. Make sure the communication interface is set properly. And again, this is all based on the manual. And I'm using Canbus. And then we need to set the Canbus speed. I want this to be 1 megabit, so I'm going to set it to 1 million versus the 500,000. Make sure I got the right number of zeros there. And then I'm going to quit and save. And then we run make and wait a little bit as the code compiles. Once that's complete, you need to get the Canbus controller into DFU mode so we can write the software to it. And so to do that, you simply press boot and hit the reset button. And once you do, the LED should change, or at least you should see both the green and the red LEDs light up. And here I will also make it a little bit darker so it's a little bit easier to see, and you can be sure you're in the right mode. Then you simply go back to the terminal on your Pi, and here we're going to do an LS USB, and we should see the STM microelectronics device in DFU mode. DFU mode needs to be there for it to accept the software. Also, make note of the ID here, copy it. We will be using that as well to identify this controller. So now let's switch into the Klipper directory if we weren't there before. And then let's run make flash underscore device, all uppercase. I'm pulling this straight out of the manual. Equals, and for some reason my copy and paste corrupted that, but we want to enter the ID here of the device, which in this case is the 0483:DF11. And then hit enter. Most likely your Pi is going to ask you for your administrator password, supervisor password, or super user password. And then that should be it. You will most likely get this error, but that's okay. As long as you see up top where it says file downloaded successfully, you're good to go. It's been programmed. Next, we set up the BigTreeTech U2C software so we can communicate. So again, I'm here at the terminal. I'm logged in at the terminal for the Raspberry Pi. And here we're going to enter Nano as a super user. and we're going to edit the interfaces.dcan0 file, or at least we certainly will if I actually entered that in correctly. So that's a typo. If you see an empty file here and you've got this little error message that a file doesn't exist, you most likely made a mistake. And so as you can see here, let me fix the typo and let me try again. And here we should see a file. I had Canbus running before, and so this was actually my old configuration. And I'm going to change it a bit based on different recommendations that I've seen. Um, One of them, at least some of these come straight out of the BigTreeTech manual, and this is to allow hot plug of CAN 0. And then I had this auto CAN 0. Apparently I don't need it, and so I'm going to comment this out. I am going to bump up the speed so it matches at 1 megabit. So again, make sure the bit rate's a million. I have that transmit buffer set to 1K, 1024. And then I've had these two lines here for a while that I'm going to keep. I don't think you need them. But again, I'm going to make sure the bit rate and buffer is set correctly here. And then we exit and save. And then you should reboot. Once the Pi has rebooted and you've reconnected via the terminal, I'm simply copying this line from the manual, and here we should see where the Canbus UUID appears. That means all our Canbus hardware is running. Canbus itself is up and running and communicating, and we have a UUID that we can now use in Klipper to instruct Klipper where to go and where to send the commands to the Canbus board. And let's copy that UUID so we can paste it in our config file. And now that it's done, let's configure Klipper. The first step is to go to the BigTreeTech GitHub site, and there is a sample CFG file. My assumption is if you wanted to, you could probably just include this in your printer.cfg file. But if you've been following any of my videos, you'll probably notice the CFG file, at least that I'm using, and that maybe influenced yours, maybe set up a little differently. But in general, the process we're going to go through is what you would expect. You've got to set the serial number that we copied previously, and here it shows you how the accelerometer is set up and configured for resonance testing. The extruder, in our case, we are using the max temperature controller, thermostat controller, and so we'll have to configure that as well. One of the other interesting items here is if you use the 2209 version of this controller, you go into UART mode, or at least you set it up as UART mode, just as you would expect anything else. However, if you're using the 2240, it actually does not support UART mode. And so here you'll see the lines are commented out. You'll of course have to comment the 2209s and uncomment the 2240s, and that's essentially what you're going to want to use. So here's my actual printer.cfg file, and I'm going to make the actual changes. So the first one being, of course, where it says MCU CAN 0, I'm going to change the Canbus ID because I used to have an EBB36, and you can see I commented the old one out and added the ID of the one I've just added. Also for the accelerometer, I've set the pin here, but because I'm using the 2240, it does not run in UART mode. It runs in SPI mode. Based on the sample file provided by BigTreeTech, here I've added in the SPI pins that are needed to make sure this works properly. And as we head down here, passing all of XYZ, because that should be using your standard MCU, there's no need for any changes there. Here I get to the extruder section, and here you can see where I've set the stop pin, the direction pin, and the enable pin. And then a little bit further, the heater pin for CAN 0. And then the 2240 and 2209 boards both contain the max temperature sensors. And I actually do have what is it, the PT1000. And so I have it connected via 2 wires. And again, here I'm enabling it via DSPI bus because, again, UART mode isn't supported. And then as we head a little bit further down here uh, into the 2240 extruder section, again, I'm setting the pin and then the SPI pins that are required. And again, that was based as what I found in the sample file. And then another thing I want to do here, if you've seen previously, well, actually, the probe, I am using tap. And so here, set the Canbus pin for tap. And then a little bit further down, the heater pin, the fan, this is the part fan, and previously that was the hot end fan. And then I normally display the temperature of the EBB36 itself, which was the CAN bus controller I had. But now since I've switched to the SB2240, here you can see the sensor, the pin is actually the same. I didn't have to change it. But here I'm going to change the name to SB2240. So when I actually take a look at this, it won't say EBB36 anymore on the thermals dashboard. And then once you've made all these changes, you want to hit save, restart. Give Klipper a little bit of time to restart here. And then when you go to the main page, taking a look at the thermals, here you can see the extruder giving a reasonable temperature, which is important. If you've got something wild, you may have the wrong pin set or something in the CFG. And I've got the 2240 set up here as well too. Notice I have EBB36. That's incorrect. But there's a really simple fix here. Just refresh your browser view and that should clear up. And we now have SB2240. And so far, this has been working great. So now that I've installed it, what are my thoughts? Well, there is one limitation, and that it's limited to stealth burner. If you're using another print head, you probably want an EBB36. However, the benefits are many, starting with the clean wiring. And this extends to the umbilical cord, the two nice thick wires along with the two thin signal wires combined in probably the thinnest umbilical cable you're ever going to get. It's perfect. And all of this, combines together to really provide some benefits to when it comes to the clearance behind the print head and the back of the gantry, which is really kind of a problem with most of the other solutions, at least on a Voron 2.4. And this essentially eliminates that as an issue. And then the CPU itself on the controller runs cooler than previous versions. And then the 2240 itself runs cooler. And then on top of it, it has a much better heat sink than it has before. And there's space for the heat sink. And then both the CPU and the driver are not mounted to the back of a really hot motor. So any of you that might have had some cooling issues, I believe this solves them. Another really nice benefit is when you pop the face off of FaceBurner, you don't have all these cables to deal with. It simply unplugs. And that also eliminates much of the risk to the cables that were plugged into the back of the controller or the standard big bundle of cables that exist, because over time I found myself destroying and having to reconnect or recrimp many of these. The circuit board also contains a PWM fan control in addition to the standard set of fan controls. For those of you that may want to add an extra fan on the shroud over there for extra cooling, you can certainly do it, and it's got plenty of space to do so with great control. Both circuit boards also connect to all the existing mounting holes on Stealth Burner, which is also really kind of nice. No modified designs, STL, no reprinting. It simply plugs right in. And then finally, there's the integrated accelerometer. No extra cables, no extra mounts, nothing that you need to connect or disconnect. It's all there, ready to go whenever you want to take a measurement and make any adjustments. It's super, super convenient. So I do have a bill tip if you decide to purchase and install this. First, I've got nothing but positive recommendations. I really love this thing. However, for clearance reasons, it uses these 1.25 connectors. It comes with what you need in the actual the kit for the SB 2240 or 2209. But I myself found I had a really hard time crimping these with the PA09 crimper, and the crimps are really small. Even with my glasses on, I had a really hard time seeing these and holding these properly. So I ended up purchasing this kit. It comes with pre-crimped wires, all the connectors you could ever want, and in addition, it even comes with the heat shrink tubing, and so this was great. If you're using Stealth Burner, the SB2209 and SB2240 are really the best CAN bus solutions out there for you. I highly recommend it. Thank you for watching. Please hit like. Even better, please hit subscribe. Thank you very much for watching.